Okay, so in this video, we're going to be talking about properties of exponents, and I actually have a whole table here that you can use as we go through these examples. You're going to want to know how to use these properties, so make sure you have this table out as we're going through the problems. If you need to make a screenshot, go ahead and do that, print it out, whatever you need to do. But we have 7 properties here that we're going to be utilizing throughout this video, okay? So you're going to have to review this as we're going through the examples. And over time, this is going to be something that you memorize. It's going to become like second nature to you. So it looks overwhelming at first, but over time, as you keep using it over and over, it begins to click, and it's pretty simple to memorize. So take a look at these, and we are going to start our first example. And again, we're going to be utilizing all of these properties in this video. So again, make sure you have it out in front of you. So here's the first problem. So looking at our first problems here, you can see that we're starting out here. And you can see that I have a base of 5 and I'm multiplying. So that goes back to the product of powers. So if you have the same base and you're multiplying, you can add the exponents, okay? So that's what I'm going to do here. I'm essentially going to do 2 plus 4 and I'll get 6. And then I rewrite it with the base that it has, in this case 5. So I'm going to put 5 to the 6th power. And I'm going to leave it like that. You can put that in your calculator and you can put down the actual value, but I'm going to leave it as 5 to the 6th power. I'm done, okay? Looking at this one here, I have division, but I have the same base. So I can utilize those properties. Now, this is the quotient property, meaning if I have the same base and I'm dividing, I can subtract the exponents. Now, this 3 here has an exponent of 1, even though it's not written. So whenever you see a number without an exponent, it always has an exponent of 1, even if they don't write it in. So in this example here, I have the same base. I'm going to utilize the quotient property, meaning I'm going to subtract. I'm going to do 1 minus 5. That will give me negative 4. So I get 3 to the negative 4th power. And then I don't want to leave my answer with a negative exponent. That's never a good thing to do. So whenever you have an answer that has a negative exponent, you want to take care of that. And you take care of that by utilizing the negative exponent property. And again, make sure you refer back to that table. But utilizing the negative exponent property, I know that this whole thing right here is really over 1. So all I have to do is bring this down into my denominator and I'm done. And that will change the sign of my exponent. So for example, it becomes 1 over 3 to the 4th power. And that would be done. That would be the proper way of writing it without negative exponents. So I'm going to go ahead and box that in. That's done. Now, to be clear here, if you had like 1 over 2, I don't know, to the negative x, okay, I can go in reverse. So I can take this part here, and instead of bringing it down to the denominator, because that's where it already is, I'm going to bring it to the numerator, and that would get rid of that negative exponent. It would become 2 to the positive x all over 1, which you technically don't have to write. You can just write 2 to the positive x. That would be the same thing. Okay, so you can go back and forth with the negative exponent property. Keep that in mind. Now, this one here is going to be a power of a power. Pretty simple. I'm just going to multiply the exponent. So I'm going to do x times y. I get 7xy. Done. Okay. Now this one here is going to be a power of a product. So all of this is being multiplied inside, and I have an exponent on the outside. I have to apply this exponent on the outside to all of the exponents on the inside. Now technically this 5 has an exponent of 1, this x has an exponent of 1, and this y has an exponent of 1. So when I apply that, it's really 2 times 1 to all 3. So I end up with 5 to the 2nd power, x to the 2nd power, and then y to the 2nd power. And I can simplify down this part if I want to. I could write 25. So 25 x squared and then y squared. That's done. Okay? So let's take a look at some more examples. Now here's our next example, a little more challenging. And here's the deal. Whenever you're given numbers or coefficients, always work with those first. So for example, I have a 4 here, and I can't combine that with anything. So I'm going to start rewriting the problem, and I'm just going to write 4. Remember, you always want to make sure that you write your numbers in front of your variables. That's why I'm starting with the number 4 here first, okay? So I'm going to write 4. Again, nothing I can do with that. And then once I write it, I'm going to cross it out so I know I'm done. Now I'm going to start with my x variable, going left to right. I have x to the 4th power and x to the negative 5th power, and this is multiplication. So again, this goes back to a product of powers. If I have the same base and I'm multiplying, I can add the exponents. So what I'm going to do here is 4 plus a negative 5. That gives me negative 1. So I end up with x to the negative 1. And now that I combined them, I'm going to go ahead and cross them out so I know I'm done. And now I go on to b. It's going to be the same thing. I have a base of b. I'm multiplying. I can go ahead and add those exponents. 2 plus a negative 2 is 0. So I get b to the 0 power. Okay? Now, I have a few more properties I can utilize here. I have the negative exponent property I can utilize right here. And then I have the 0 exponent property I can utilize right here. So going left to right, using the negative exponent property, I'm going to take this x to the negative first power and bring it down to the denominator. So I'm left with 4 all over x to the first power, but I'm not even going to write to the first power. I'm just going to leave it as x. That is the same thing. Now, this b to the 0 power is technically going to be 1. So I'm technically done with the problem. Now, real quick, why is something to the 0 power 1 anyways? That doesn't really make sense. But what you have to remember, I can factor out a 1 there. So for example, I have b to the 0 power, right? And logically, when you look at that, you would think, well, that's like nothing. But I could take out a 1 from this part here. So if I factor out a 1, right, that makes it a little more visual. You can see that there's actually a 1 occurring here. So even though this whole part right here essentially cancels itself out, I'm left with 1. So that's why anything to the 0 power is going to be 1, right? You can think of it like that. But this right here is going to be my final answer. That's done, okay? All right, let's try a few more problems. So here's my next problem. It's division. Now, whenever you are given division, here's my recommendation to you. Simplify the numerator, then simplify the denominator, and then go from there. So looking at my numerator, I can't do anything. I just have 4 and then x. But then if I go to my denominator, again, we always want to work on the coefficients first. This 4, I can't combine it with anything. I'm just going to write it out in front. So I'm going to write 4 and then cross it out so I know I'm done. And now I can work on combining these exponents. I have the same base of x here, and I'm multiplying, so I can add the exponents. Now, technically, this x has an exponent of 1. So what I'm doing here is 1 plus 5, I get 6. So I get x to the 6th power. I'm going to go ahead and cross these out so I know I'm done. And then working on my y variable, again, I really have an exponent of 1 here. I'm multiplying, have the same base, I'm going to add. Negative 2 plus 1, I get negative 1. So I get y to the negative first power. And now we can clean it up. So 4 divided by 4 is 1. They essentially cancel each other out, all right? And now I have x to the first power, right? And I have x to the 6th power. I'm dividing, meaning I can use subtraction. Again, this goes back to the quotient of powers. Make sure you are referring back to that table if you need to. So if I do 1 minus 6, I get negative 5. I get x to the negative 5th power. And then I have this y all by itself down here, y to the negative 1. Okay, so I'm going to write that in. And remember, we never want to write our final answer with negative exponents. So utilizing the negative exponent property, I can take this guy right here and bring it down. And again, remember, we can go in reverse. So I can take this one as well and bring it up. So the final answer is going to be y to the first power, or just y. So I'm going to write y all over x to the 5th power. Okay, and that's done. All right, let's try 2 more examples. So here's our next example. Again, more division. So work on the numerator, then work on the denominator, and then work on simplifying it down. Now, I like to work on my coefficients. So I'm going to do 3 times 4. That will give me 12. So I'm going to put 12 here, and then I'm going to cross them out so I know I used them up. Now look, x to the 0 power is 1. It essentially cancels itself out. So that's what I'm going to do. All right, and technically this x right here has an exponent of 1. Same thing with this y. So I'm left with x to the first power, or just x. And then working on my y's, I'm multiplying. I have the same base. I can add the exponents. 1 plus a negative 3, I get negative 2. So y to the negative 2 all over. Well, here's my 4. Can't do anything on the denominator there, so put 4. And then x to the negative 3 and y to the 5th power. Okay? So from here, let's simplify it down. Let's work on the coefficients. 12 divided by 4 will give you 3. So I'm going to write 3 here. We use these up, we're good. And then looking at my x variable, I have a exponent of 1 here. I'm dividing, I have the same base. So I'm doing 1 minus a negative 3. And if you want to write it out, go for it. It's 1 minus a negative 3. These two negatives make a positive. You're left with positive 4. So really, it's x to the 4th power. Okay? So this is done. This is done. Working on my y variable, it's negative 2 minus 5. That would give you negative 7, right? So y to the negative 7. And then utilizing your negative exponent property right here, we can bring this whole part down. So I'm left with 3x to the 4th power all over y to the 7th power. And there we go, we're done. Okay? So let's try one more example. So here's our next example. It looks challenging. It's not though. You just have to work from the inside out. So for example, this negative 2 here on the outside, I'm not even going to worry about it until the end. Okay? My main focus is going to be working on the inside here. So we have division. First, I'm going to work on the numerator. Then I'll work on the denominator. I'll simplify it down. Then I'll worry about this negative 2. Okay? So looking at our numerator, you can see that I have y to the 0 power. I'm going to go ahead and cancel that out because technically that's 1, right? So I'm left with x to the negative 4. So x to the negative 4 all over, now going to the denominator, I have a 3. Can't do anything with it, so I'm just going to write 3. Cross it out so I know I'm done. This right here, I have x to the negative 6 and x to the negative 1. I'm multiplying. I have the same base. I add. So I get x to the negative 7 and then y to the negative 2. Again, these are done and done, right? So from here, what can we do? Well, I can keep simplifying it down because I have the same base here and here, and I'm dividing. So I can go ahead and subtract there. So I'm going to end up subtracting. I get negative 4 minus a negative 7. Okay, just writing it out. So you can see here that these two negatives will make a positive, right? It's negative 4 plus 7, or in other words, you're going to get 3 here. So x to the 3rd power. So I'm going to write here x to the 3rd power all over, and I get 3, and then y to the negative 2. Okay? And remember, I still have this in parentheses technically, right? And I have this negative 2 on the outside. So from here, we can use a power of a quotient. And what that essentially means, this negative 2 is going to be applied to all of your exponent values inside. So that's going to go there. It's going to go here. And it's also going to go here to this 3 that has technically an exponent of 1, right? So when we do that, we get x to the negative 6th power. I'm going to write that right here. X to the negative 6th power, right? And then we get 3 to the negative 2. And then we get y to the 4th power. Okay? So there's a couple more things we can do here. I can use the negative exponent properties, and I can bring this guy down, and I can bring this part up. So if I bring up 3 to the negative 2, it becomes 3 to the 2nd power, or in other words, 9. So on my numerator, I'm going to have 9 all over, and this part here, I'm going to bring it down, x to the 6th power, and then y to the 4th power. And that's done, right? So that is properties of exponents. It does seem a bit overwhelming at first, but once you understand the properties, it's going to become like second nature. And over time, you're going to naturally memorize it. So again, it does take a little bit of practice, but the more problems you do, the more proficient you're going to become in these properties of exponents. So I hope that you found the video helpful. I hope that you gained something from it. If you did, in fact, gain something from the video or it helped you, please go ahead and give it a thumbs up. Also, make sure you subscribe to the channel so you get more math videos in the future, and I'll see you in the next one.